All right, this is my third video on using the rational root theorem. So we're going to find all zeros of this polynomial function. We're going to do that by factoring. So again, we're using the rational root theorem because our polynomial cannot be factored. So we use the rational root theorem to allow us to get to a point where we can break this down and factor it. So the way the rational root theorem works is we're going to have a list of P and Q. So if you've watched my other videos, P comes from our constant, which is the back number, and we want all factors of 8. So that's going to be 1, 2, 4, and 8. Q is going to be the factors of my leading coefficient, which in this case is 3. So the factors of 3 are 1 and 3. So what I'm going to make here is my official list of all possible rational zeros. It's going to be a list that's positive or negative. We're going to take all of the values in my P list and divide by each of the values in my Q list. So I'm going to do 1 divided by 1, which is 1. 2 divided by 1, which is 2. 4 divided by 1, which is 4. 8 divided by 1, which is 8. And I'm going to repeat that process, but now doing it dividing by 3. So 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 4 divided by 3 is 4/3. And 8 divided by 3 is 8/3. So this list is the list of all possible rational zeros I'm going to get for this function. So the next thing to do is we're actually going to use our calculator to kind of help us through this. Is we're going to take our calculator and do y equals, and we're going to plug in 3x cubed plus 14x squared plus 20x plus 8. So I've already plugged it in for us. So when you graph it, there's the graph. Great, grand, wonderful. Most importantly, what we want is we want the table of values there. So we're going to do second and hit graph, which takes us to our table. Now what we're looking for is we're looking for which x values give us a y value of 0. So you can arrow up and down and look around and you'll see that -2 gives us a y value of 0. So what I'm going to do is I'm going to do some synthetic division. Since I used my calculator and found -2, I'm going to put -2 in the box. So what we're going to do is we're going to do synthetic division to show that yes, in fact, -2 is a 0. So I'm going to have 3, 14, 20, and 8. Now when I'm doing synthetic division, again, we're going to add down, multiply up by the box. So adding down, I get 3. Multiply up, -6. Add down, 8. Multiply up, -16. Add down 4. Multiply up, and that is -8. Add down, we get 0. So what I've shown there is that -2 is in fact a 0 because we got a remainder of 0. So since -2 is a 0, and I've shown that here, I can now write x plus 2 as one of my factors because that is the factor associated with a 0 of -2. Now what we want to do is we want to look at this piece. So I have that 384 there. What this 384 represents, that's 3x squared plus 8x plus 4. Now that is something that I will tell you this can be factored, but a lot of times, a lot of students at this point, either anxiety of the tests, they can't remember how to factor it. If you remember how to factor this, great. Go ahead and factor it. Higher level math students, they should be able to know how to factor this, no problem. But say you just don't remember how to factor. Well, what you want to do is you want to try another 0. So what I would do is go back to my list and look for, what's another number that gives me 0 for y. And we could keep scrolling up and down forever. You'll find it. You're never going to find it. The only number we have is this -2. Now what you want to remember is on several problems that I've worked in class, sometimes we have our zeros or our factors duplicate. They show up more than once. So I'm wondering if maybe -2 shows up more than once as my factor and my zeros. So what I'm going to do is I'm going to try -2 again. So I have 384. I'm going to try -2 again and see will it give me and show me that it's another 0 again. So I'm going to do synthetic of division again. I'm hoping I get a 0 for my remainder. So adding down, I get 3. Multiply by the box, 3 times -2, I get -6. Add down, 8 plus -6 is 2. Multiply by the box, -4. Add down, and we get 0. So what I just showed is I got a remainder of 0 again. So what that means is I got x plus 2 as a factor, but I had it happen again. So I have x plus 2 and x plus 2. The only thing left to do is if I take this, my answer left over here, not the remainder part, change this back to a polynomial form, that's 3x plus 2. Well, that is something that's completely factored. That's as basic as it gets. So I'm going to have 3x plus 2 up here as another one of my factors. This is the completely factored form of this polynomial. Only thing left to do to find the zeros is once you're completely factored, the entire polynomial is equal to 0. I just need to set each of my factors individually equal to 0 and solve. So I'll be taking x plus 2 is equal to 0, solving. X plus 2 is equal to 0, solving. 3x plus 2 is equal to 0, and solving. And when you solve each of those, you're going to get x is -2, x equals -2 again, and when you solve this one, you're going to get x equals -2/3. So that is all 3 of my zeros. So that is finding all the zeros of the following function using the rational root theorem.